All right. So the only reminder I want to have for you, next week this time, you will have your project due in the midnight, right? For your project. Just make sure, get it ready, right? I'll give you the final submission guidance, but there should be no surprise. You basically got to submit a zip file of your projects, including the 10 examples or any additional ones, plus the report. That's it, all right? Anyway, I'll reach out to you about the submission guidance. And for today, we're going to continue with the bottom-up parsing. Not finishing that just yet, but hopefully most of it on Thursday. But today, there's only a few ideas I want to carry over. Okay. First of all, I want to revisit this particular tracing that we did last time. If you went over the recording, I'm pretty sure you did, or you were there last Thursday. This is what we did about the tracing for bottom-up parsing, right? We talk about reduction versus shift, right? So these are the two main actions we may do. And of course, we talk about the stack over here. And I mentioned there is one word which I'm going to elaborate, which is about the idea of handle. That's what we're going to cover today. Okay, let's see what a handle is. Briefly speaking, a handle simply means the state of your parser somewhere in the stack that's actually ready for reduction. It's actually written in the notes, but let me show you what I really mean. It's really important idea about handle. If you ask about what's the essence about bottom-up parsing, it's about handle. Let's take a look. I want to talk about two things to actually explain the handle. One will be just show you what a handle is, and the second one is I want to revisit about the idea of rightmost derivation. Okay, let's do the handle first. And if you remember this particular stack, of course, if you got any trouble on recalling it, watch the recording, okay? And that's the corresponding table that we had, right? That's the stack contents. And today, I'm going to explain to you how to interpret this particular column, which is called handle over here. Okay, over here. You can see some of them simply say none, means not applicable. Some of them actually got some stuff over here for the handle, all right? Think about the handle simply means, for example, this guy over here. This is a handle. So this means this is a state of the parser that's ready for reduction. And what reduction exactly should we do at this stage? If you remember, we actually looked up the table and we found that it should be R5. That's what we had last time, right? Reduce 5, meaning that we're going to use rule number 5 over here to do the reduction, right? That's what we did last time, okay? So this is called a reduction. And let's recall just a little bit more. What exactly did we do? You can see that over here in the stack, this is what we got. You can see we got the opening parenthesis, some state number over here, closing parenthesis, and some state number here, right? We talked about the pair last time, okay? And the way we did, once we find a handle, we're going to replace this guy over here by the pair. That's basically what we did. So I want to highlight this part here. That's something you will just want to make sure, revisit the table, convince yourself. This one here and this one here. We basically reduce these two symbols into pair, which correspond to this particular alternative production rule, right? So once you have done that, you're going to replace that by just a pair. That's what you saw last time, all right? So what we have seen so far, I just want to link the table, especially the handle column over here, back to the stack. So whenever you are in a state in the stack where you're ready to do some reduction, meaning that you have some R action, in that case, it's a handle, okay? We're going to see some very interesting combination of different states for the bottom-up parser. That's something we'll see a little bit later today. But that's the first part. Are we okay so far about handle? Okay, it's a state that's ready for reduction. Number two, I want to revisit this idea. When I first introduced the idea about bottom-up parsing, I sketched very, very abstractly. If you try to recall, let me just show you the diagram I used to draw, but I'm going to make it much better today. This is a diagram I drew, maybe about last week or maybe 2 weeks ago. I said The way we're going to do the bottom-up parsing is going to correspond to the reverse of the rightmost derivation. I kind of sketched the idea very abstractly. But now I'm going to show you how you can see concretely how it is done, okay, using the tracing very quickly. So what the example I'm going to use, let me go back, is over here. So this table here is on your slides. Okay, let me just go back here and show to you. It's on slide 64, right? So that's the parsing process for this particular input, all right? And of course, you got to make sure you actually understand how this one is derived and make sure you're convinced. And I'm going to use this table over here to illustrate to you is indeed the process of the bottom-up parsing correspond to the reverse of rightmost derivation. How? Okay, let's take a look. We're going to focus on all the handles and to see how the handles will actually build up the parse tree. That's basically what we're going to do. Okay? Let's now take a look. Let's see. First of all, let me highlight the handle part, which is here. And for those that are simply just none, you can know that they simply correspond to the shift operations, which we don't have to worry for the handle, right? We're going to focus on this one here, 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 and this one here. So these are the handles we can see to see how the parse tree is going to be built. All right, let's see. Let's start with this one. This one means so far we have read opening parenthesis and closing parenthesis. By applying rule number 5, we can reduce this guy over here into a pair. All right, let's now highlight it. The first one I want to do is this guy here is reduced to pair using rule number 5, right? You can see reduce 5. Let's now write it. So this one is telling us we got this one, and then they are reduced to pair. Okay? And then we got another one. Another one is to say, so far we have read opening let me just use the highlighter. We have read this one here, meaning that this is the pair we have reduced so far, but we also read some surrounding opening and closing parentheses, right? And we can also reduce the whole thing into a pair using rule number 4, right? You can see that's exactly the rule, right? That's how you read the table. All right, let me just do that. So here you can see it can be reduced to this using rule number 4 for reduction. And how do I draw that? Okay, let me move this a little bit. So that means we have read surrounding parentheses, and all 3 of them will be reduced into a pair by using rule number 4, which is over here. All right, so far so good. And the next one. The next one, we say that for this pair over here, we're going to reduce it using rule number 3, which is over here. So list produces pair. That's what we can reduce. So we're going to reduce pair into list. Okay? So let's try this again. So we're going to reduce that into a list. Okay? So far, so good. Let's get to almost the final one. Okay? And here we also got another one here. Let's say, how about purple? Okay, we read another independent pair of closing, like a pair of parentheses. And then we can use rule number 5 again over here, and then it's going to be reduced into just pair. Okay, let's see. So what we have is this part over here is going to be reduced to just pair. And according to rule number 5. Okay, the final one, you can see here, we got list, we got pair, we got list, we got pair. According to rule number 2, we can reduce them into just a single list. Agree? Okay, and this part over here is pretty much corresponding to the original input. So we're pretty much done. Okay, let's do a final reduction. And then I'll show to you the important remark. Okay, so let's now do, what color can I use? Maybe red. Okay. And so we got list and pair using rule number 2, which is over here. we're going to reduce that into a list. So list and pair reduce into a list. Okay? That's when we are ready to accept. Okay? And now, why is this corresponding to or related to rightmost derivation? Okay? Let's try to do the following. First of all, let's recall. The order of reduction. If you think about it, we did this one first, right? And then this one, and then this one, and then this one, and then this one. Agree? That's exactly what we did. If you're not convinced, you can rewind. Okay? And that will be basically 1, 2, 3, 4, 5. 1, 2, 5. And the important question is, what about the order of rightmost derivation? It's going to be, we start with this. The rightmost will be this one. And then we go with this. What will be the rightmost under this? Just this. What will be the rightmost under this? It will be this. So that's exactly 5, 4, 3, 2, 1. Reverse. So this really confirms about the observation we had. So now, what's really the important remarks up to this point? We learned about the top-down parsing. And that one there simply corresponds to leftmost derivation. For the rightmost, for the bottom-up parsing, it's not exactly rightmost derivation, but it's reverse. So very closely related to. That's really important for you to know. Okay, any question about this? I think this will complete the picture about our introduction to bottom-up parsing. Okay? Everybody's okay? I hope that's clear. Okay. And let me just go back to the slides. And then what I want to talk about today is just to introduce the idea about LR1 items. Okay? It's a kind of interesting idea, very symbolic that we have to learn. And then next time we'll talk about the algorithm of how to build the actions and go to table. Right? So the action and go to tables, they will encode legitimate ways to find handles, basically about ready states for reduction. Okay? We just talked about handles. And this guy here would be the syntax you will have to know. Okay? Let me explain that quickly. Okay? So this is something called a LR1 item. If you remember, bottom-up parsing is about LR1 parser, right? Do you guys remember what LR and 1 stands for? Quick check. L? Anyone?
Left to right.
Left to right, thank you. What about R? Rightmost derivation, which we just saw, right? How about 1? One look ahead, exactly. Thank you. Okay, just remember. It's a very easy question to definitely answer in the exam. All right, let's now take a look at this. Okay, let's start with something simple. By the way, so every LR1 item, you can think about every time you see a single LR1 item, it's about a possible states of your bottom-up parser. Okay, that's how you can understand intuitively. Possible states of parser. And every time you want to describe it, you want to make sure you enclose the contents within a pair of square brackets. It's just the way it is. Okay? And let's look at more detail. Number 1, you can see the first component over here is about some reduction rule. So here, the reduction rule that we have is, so this is a reduction rule or production rule. You know, I think production rule is the right term, right? Because we talk about different alternatives for the reduction. So this will be a production rule. Okay, so in this case, A produces beta followed by gamma. All right? And what about this bullet point? I'll get there in a moment. Okay? And what about this A over here? A over here is the look ahead. More precisely, it is a member of the follow set of A, which we ultimately want to reduce into. All right. So how do we interpret this? You can also see the slide later. Our goal is to eventually reduce into A. In order to reduce into A, we have to first match beta and then match gamma. That's what we have to do. Once we get to this point, having already recognized beta and gamma, we will be in a handle, in a ready state to reduce back to A. Okay? But what about the current states for the parser? This will be this bullet point you have to watch out for. So this bullet point here is the current. You can think about the current position or current top of the stack. Think about this is the stack of the parser. And we have already, so maybe there might be something else, but the top will be just the beta. That's what we have recognized so far. And we are now at a stage where we have already matched beta. We have not really matched gamma just yet. Ultimately, once we got gamma also over here, we will be ready to actually reduce these two guys back to just A. So that's kind of the idea. All right, let me write it down. That's how you can understand this notation, because we need to worry about how this dot over here may float in different position to represent different states. Okay? So you can think about over here, once we recognize, okay, let me say two things. Number one, we have already recognized beta. Already recognize beta because it's the top of the stack. It's already there. Once we recognize gamma, we will be in a handle which is ready for reducing into A. Right? So the critical point you want to watch out for is beta, gamma, and also A. Right? Are we okay so far? That's how we represent the states. Oh, we'll do exercise, don't worry. Also, I will assign some exercise to you too. Okay? All right, so that's about the notation. Let's see the next part. Right? Everything has been set. All right? The only detail which I didn't quite mention, which can easily also be derived. So whenever you try to replace, maybe once you have, let's say once you have read through beta and gamma, of course, their corresponding state number should be replaced as well, right? That's how we did it for the tracing, okay? That's what you will see in the slides to be more precise. And let's now talk more about how this LR1 item may float, okay? So there are three terminology that we have to, well, three terms we have to know. One is called possibility, the other one called partial completion, and the third one is called completion. Let's go over one by one, okay, quickly. Okay, let's go over. Okay. Why don't you guys just stare at this one, and this one here. They look similar, but they are not the same. Okay? Why don't you stare at that just for 1 minute, and then I'm going to explain quickly how to understand them. And then we'll do some exercise. Okay. Another moment. Okay. Of course, the main thing to notice is about the position of the bullet point. For the possibility, it's almost like the beginning of the parsing, in which case, you can think about the top of the stack has read nothing, so it's empty. And about partial completion, we might just be in the middle. We have recognized something, and we are still expecting to recognize more before we can do reduction. And here, the bullet point is at the end of the production rule, in which case, we should be ready to reduce back to A, as long as the current word will match this look ahead symbol. Right? Let me talk about them one by one very quickly. You can also see the written notes on the slide. For the first one, let's now take a look. this will be the initial state of parsing towards reduction to A. Our ultimate goal is to make a reduction into A. To really do that, we got to recognize beta first and then recognize gamma. But so far, we have not recognized any one of them. We're just in the beginning. Okay, that's the beginning, initial stage. And this will be the partial stage, which pretty much is like this. Okay, that we just talked about. And for this one here, you can think about we got a stack. We already got beta on the stack, but we're still expecting gamma to be read into the stack, right? So this will be already recognize beta and then still expecting to recognize gamma. And hopefully we can recognize gamma and then we should be ready to reduce back to A. That's the intermediate stage. And of course, in general, you don't necessarily just got two components for the production rule. It could be several, right? This is just symbolic, just for illustration. And a final point to make. If you look at this one, the bullet point is at the end of the components. So that means we have already recognized all the components we actually expect to really recognize. So let's draw the stack very quickly. For this one here, if you think about a stack, we have recognized beta, and we have recognized gamma. And then here, you have to pay more attention to the look ahead symbol. Okay, so this will be a member of the follow, right? The follow of the variable here that we want to reduce into. Okay, so now this is the idea. If the current word matches the look ahead symbol A, then we can reduce. Okay, you only consider the look ahead symbol in the final stage. All right. That's about the very quick walkthrough about different stages. And we're going to do exercise to make sure you're able to actually manipulate such symbol. Okay, that's what we have to do today. And then next class on Thursday, we're going to see how you can use this kind of manipulation to create the table. Okay, that'll be the idea. All right. Any question until now? Are we okay? All right. Let's now take a look. Okay, good. Let's do some quick exercise together. Oh, sorry. I should really switch. There we go. Over here. Simple question. Okay. Let's say this is some concrete grammar, some example grammar, which we just did, right? Two questions for you. What would be the corresponding LR1 item written in this particular syntax? What would be it to correspond to the initial states of the parsing? And also the final states of the parsing, if it succeeds. Question one, how should we write it? I can start you up. It should be something like this, right? Okay, what else? Well, something should go here, and something should go here, right? Jordan, go ahead. Yeah, okay, I agree. Remember, the syntax tells you you should really put some production rule. So why don't we say, which production rule should you put? Okay, I got 1, 2, 3, 4, 5. Which one? 5? But we talk about initial state, right? Think about initial state. That means what in the initial stage, what kind of a rule do we expect, or what kind of symbol do we expect to really match ultimately? You should really look at this guy here. because we start with the goal, the start variable. Ultimately, we want to match a list, which can be reduced back to the goal. That's our goal, right? Okay, good. Why don't we write it down first? So this one, I'm going to wipe it out. It's going to be the goal produces list. Now, where should the bullet point go? Should the bullet point go here? Should it go here? Should it go here? Should it go here? Or should it go here? I'm teasing you guys, but where should it go? If you write this in the exam, wow, too bad, sorry. You will make me laugh, but sorry. I got to do the right thing, right? Okay, guys, any idea? In the beginning, right? Swap. Before list, absolutely. Okay, guys, this is an easy one. Okay, put it here. So this means we are in the beginning stage. We haven't read anything just yet, but we're expecting to match the list ultimately. Okay, and what about this part here? By definition, this part over here should be the follow set of the variable that we want to reduce into. So this should be a member of the follow of this goal. And I can tell you that the follow set for this one is actually straightforward, given that it is the start variable. What should that be? And the file, absolutely. Okay? It turns out there's only just EOF over here. So only put EOF over here. Okay? I thought we're good. Just to get you a little bit more familiar with the notation. All right. How about this one? Now you guys should feel a little bit better. How about this one here? Okay, let me also start you with first. And which row should we put? 1, 2, 3, 4, 5. Robbie? 5? Okay. I tell you, Robbie, what the problem might be if you put 5. Let's say we put 5, for example. If you say you put 5, produces this and this, right? And maybe it makes sense to put a bullet point right here, right, at the end. I tell you why this would not be a general answer. This only tells you that you have matched a matching pair of brackets. But if you go back, for example, to where we were over here, this would be some state like here. Is it the final states? Not necessarily. So that would not be a good answer. Good try, but you should know why it's not a good answer. All right? Okay? Okay to be wrong at this stage. If you don't mind, I'm going to say cross, not necessarily the final states. Okay, another try. Swap. Yeah, that makes more sense to me. Because if you guys remember, let's see why. If you go back to this table here, basically, ultimately, we want to reduce back to the list. Once you go back to the list, you can think about list can be reduced directly back to goal, right? Yes, I agree. Okay, let me put it here. So that'll be the ultimate answer. So here, okay, just remember the syntax. Syntax is really important, right? So it's going to be the goal produces the list. But this time, the bullet point is actually going to go to the end over here as opposed to the beginning, if you see the comparison. And the follow set would just be the same, just EOF, the same. Okay, good, easy question. Let's now do something a little bit more sophisticated, okay? This is a question. Okay, I'll try to explain a little bit. This one is kind of symbolic, but we'll do something more concrete once we pass this stage. Let's say we have a single production rule. A produces beta, let's say, okay? And the question is, we want to derive all the LR1 items for this. I can tell you that you cannot, because we don't really know exactly what beta is, So we can only try to use maybe like a formal notation for that. Okay? So what we really want to do is by using, I'll give you a little bit hints. Somehow the answer should really contain a union of several combinations. Some union. And then also set comprehension. And also there should be some floating bullet point. This will be my hints to you. That'll be the answer. Why don't you guys think a little bit, just for 1 minute. Okay, I'm going to go over the answer with you. Answer is on the slides, but it's easier too. It might be more effective. I can just develop from scratch together with you. Once we understand the answer here, it will be applicable to any concrete example, which we're going to do. The answer is going to be something like this. Some set comprehension, union with maybe another set comprehension, something like that. Inside the set comprehension, we want to somehow play with the position of the bullet point, somehow. All right? I just noticed that there was a very terrible typo from my end. I really meant to put gamma as well. Sorry about that. I'll just change the question on the fly. I really meant to do that, so that will be more interesting, not just beta. Okay? Okay, let's now work out the answer together. 2 dimensions. Dimension number 1. Dimension number 1 is about the floating position. Floating positions of where the stack top is. It could be, for example, let's say we got A produces beta, gamma. It could be exactly in the beginning, right? Or it could be A produces, maybe we have already recognized beta, and we are now at the point that we are expecting to match gamma. Or it could be that A produces, we have already recognized beta and gamma, and we're now at this stage. That's dimension number 1. So we got 3 possibilities. Of course, think about in general. If I know the length of the components, how many possible floating positions do I have? Right? Think about it. Okay? That's dimension number 1. What about dimension number 2? Dimension number 2 would be, if you look back to the syntax over here. Here you can see A, as I said, it would be just the follow, a member in the follow set for the variable that we want to reduce into. In general, this will be a set. Let's say the set has cardinality, let's say 3. Let's say we got some symbol X, we got some symbol Y, we got some symbol Z over here. In that case, A here can either be X, can be Y, can be Z, right? So that's the second dimension. You want to do combinatorial. You want to do some combination. Okay? This will be the follow set of A. So this will be the intermediate hints I can give to you. After understanding D1 and D2, we should be able to derive the ultimate answer. How can we combine them together to say these are the set of all possible items for this particular production rule? Okay? Anyone would like to give it a first try before I tell you the answer? Why don't we start with this one here? Okay? Basically, we want to say we want to have just a beginning stage. If we have the beginning stage, okay? Let's say we have the beginning stage, which will be A produces here, beta, gamma over here. But what should we put over here? The lookahead symbol. The lookahead symbol here can be any member of A. Any member of the follow set of A. So we cannot put just follow over here. It's not allowed. It should be a single symbol. So that's why set comprehension could be useful. All right, I'm going to write it down directly to save time, but you want to make sure you understand how it is derived. If we simply put, let's say, A over here, okay, let me just put it over here, okay, just give myself more space, such that A is a member of the follow, okay, just a little bit more space, actually, follow of A. And this is a set. Okay, let's see what I'm doing here. This particular set represents all the possible LR1 items where you're in the beginning stage of the parsing, but the look-ahead symbol is just a member of the follow set of A. Right, so this really represents all the possible look-ahead symbols for you. This will be one set. Can you guys complete the rest? Right? You can just do something similar. This will be one. And why don't we, so this part would really be similar. It's just that the bullet point is going to float. So we're going to say union with A produces beta. We have recognized it, so now we are here. Gamma and then A, such that A is a member of the follow of A. The second one, right? You can see the only thing that's changed is about where the bullet point is. And there should be another one, the final one. A produces beta, gamma. We have matched these two, and we are now here. And A. And A is a member of the follow of A. And notice that here. Right? This will be the ultimate answer, right? For any production rule that you have over here, you basically have to figure out all the possible floating points and then combine that with every possible look-ahead symbol and work out a set, right? That's an abstract example here. We're going to do a concrete one, and then we are done for today, all right? Any question up to now? Okay. Let's now take a look. Okay, that's something we have seen already. Okay, yep, that will be the answer we just derived altogether, right? Okay, let's now take a look at one more exercise over here. Oh, one thing to ask you guys about, which would be relevant. Oh, just before that, why don't we try this one first? Okay. Now, rather than just dealing with A produce a beta gamma, we actually got a concrete production rule. Pair produces parenthesis pair followed by parenthesis, right? That's a production rule. So now, can we derive all the LR1 items? And this is given to you. Of course, in the exam, this might be something you have to calculate. But for now, let's say you're given this. Number one, before we derive, how many LR1 items do we have to enumerate? How many? In order to figure out how many, you will have to look at two dimensions. How many possible floating points? And how many follow set for the relevant variable which you want to reduce into? Okay? How many floating point possible? 4. Okay, I agree. Here, 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 or here. Okay, 4. So, possible floating point position would be just 4. The point can be here, can be here, can be here, or it can be here, right? After each component and in between. And second dimension. So now, which follow set should we look at? Should we look at a follow set for list, or should we look at a follow set for pair? Pair? Agree? Exactly here, right? Okay, good. And also, the cardinality of the follow of pair. And of course, you can put this notation if you like, right? Just its cardinality. Right? So what would this be? Well, given that 1, 2, and 3, which would be 3. So in total, you're going to get 12. Okay? Let's numerate them all. That'll be the last thing we do. And then I'll cite an exercise to you. All right? Let's take a look. Why don't we start with the initial one? Initial one is going to be pair produces, and then bullet point right here, this pair, and like that. I want to write it better because I'm going to do copy and paste very soon. All right, and what will be the possible look-ahead symbol? It could be EOF, right? It could be, right? Let me now do some copy and paste. 1, 2. Oops, sorry, let me do it again. So in this way, you can see exactly how you can derive it yourself. But let's now 3, and of course, I can make it just smaller. So I can fit everything. 1, 2, 3. Oops. Okay, 1 here, and I got some extra over here. So it can be EOF. It can be opening parenthesis. It can be closing parenthesis. Oh, just 3. I beg your pardon, just 3, because the cardinality is 3. Are you guys okay with what I have done so far, right? For this particular floating position in the beginning, the look-ahead symbol can either be EOF, or it can be opening parenthesis, or closing parenthesis, corresponding to the member of the follow set for the relevant variable. Okay? Now, how can I complete the rest? Well, for each one of the others, pair, well, like a block, you still have to numerate EOF and this, right? But now what should change? The floating position. All right? And let me do that. The first one is going to be right here. So I don't have this anymore. So I'm going to put just here. 2, 3. Are we okay so far, right? And to really make sure I can fit everything, I'm just going to make it even smaller. Okay. I think that's good. Yeah, so you can actually see the final answer. Okay, and we need 4 in total. Right here, right? How should we change the bullet points for these? This one here, oh, you know what? Let me just make sure. 1, 2, 3, and also 1, 2, 3. Okay, let's now try to mark it. So for this, in the beginning, for this, after matching opening parenthesis, and for these, it would be after matching the pair. So I'm going to put a pair over here. And for the final one, it will be after matching everything, which will be here. All right? That's what you will have to do if you're given a question like this. Can you do copy and paste? Too bad you cannot. I could. You cannot. Okay, good. All right, guys, I hope that's clear at least, right? Okay. So the idea would be when you try to construct a table for action go-to, you will have to understand the kind of underlying fundamental ideas. That's why we want to cover this first before we get to Thursday lecture. All right? And some exercise for you, and then we are done. And for your exercise, you will have to compute, let's say, okay, two exercises for you. Number 1, given this particular grammar, you want to derive all the LR1 items, and these are all of them. All right? So you can try to convince yourself these are all the possible states for the parser. The answer is already there. For example, you can see this. Let's say here, this is what we just have done. Right? Okay, make sure you get yourself convinced. That's exercise number 1. Exercise number 2. Given this grammar, derive all the LR1 items. Okay, I would suggest before you even try to enumerate all the possibilities, come up with how many there should be. That should be easy for you to predict, and then try to enumerate them. Okay, I may not necessarily ask you to come up with the LR1 items for the whole grammar in the exam. I might just choose maybe 1 or 2 production rules, but it's hard to say. Maybe I'll give you a smaller grammar for you to enumerate, but at least you know how to do it. All right? All right, so these are the 2 exercises for you. All right, I'll leave that to you. Any question? All right, if no, we'll call it a day right now, and then on Thursday we'll dive into more about the table construction. And just don't forget, you got exactly 1 week before your project's due. Okay? I'll see you on Thursday. Take care.